All right, this video is going to demonstrate how to create a 2D game for Unity based on the items that we did in class to go from a base game of nothing to a sample game with movement, shooting, enemy spawning, um, some UI elements, and scene changes, um, and a little bit of sound. So first thing is in Unity Hub, create a new 2D game. Here we are presented with our um, base layout. And if you go up to pick the workspace, you can arrange your workspace in different layouts. This is a layout with a stack of two different display windows on the left-hand side. There are other layouts that include um, having larger um, screen layouts and or like the scene and the game layout, and there are other ones that can emphasize the hierarchy or the inspector, etc. I think this layout is fairly effective at displaying the information that is necessary. I like the two stacked full screen images on the left hand side. So what we're going to do is we're going to save and we're going to create and save some scenes. So this first scene we're going to rename and save it as the play screen. Then we will close that and create some other scenes. We will eventually need a title scene and a end game scene. So we will create those now. You don't have to create all of your scenes right now. You can create them as you need them, but I like to just kind of get things cleaned up because um, it seems to interrupt my workflow when I want to eventually get to the point where I want to swap scenes that I like to have them already in and already in the build manager. And here in the build manager, build settings, you can import the scenes that you currently are working on. So I can add the open scene there. And then I'm going to close that scene, open the next scene, add it to the build manager, etc. There's probably a faster way to do this, but I didn't know it off the top of my head. The scenes need to be added to the build settings in order to be able to use code to switch between the scenes. Here I'm just putting them in order so that I can refer to them as their numbers, 0, 1, and 2 for title screen, play screen, and end screen, but we can also refer to them by their name. All right, in the assets folder, I like to create some subfolders to keep my various assets for a game in an orderly manner. And so I usually create a folder for sprites, a folder for animations, a folder for um, sounds, etc. So here I'll create each of those folders. And now let's import some assets into our sprites folder. So we're going to use a simple set of the robot, box, ball, and bullet type items. When this imports, we want to make sure that this is imported as a sprite type and then with multi selected in our sprite mode. This will then automatically slice our objects, but the names on this individual slices on individual sprites will be meaningless. So a lot of times I like to open the sprite editor and then slice them. If you didn't automatically slice them, you would need to open the sprite editor and slice them. This should put these bounding boxes around each item, and then you can click on the item and rename it. So all right, those items, to rename them, you click on them in the scene in the properties window by highlighting the sprite that you're currently working on and save their names. So we can make the first one ball, the second one box, etc. So work through your assets, renaming them here, and when you are finished, you will hit apply and close this window. So now everything in your inspector has reasonable names. Your sprites actually are named similar to what they look like. All right, it's time to begin building our scene here. So we're going to use TextMesh Pro objects on our UI. So this is building the title screen. So when you add your first TextMesh Pro item, you'll be prompted to import these resources. You should import both of these. The second one isn't 100% necessary, but it does include some other things like fancier text, fonts, and some styles. So once we've put our first TextMesh Pro item in, you'll see in your assets folder that it's included a big folder of a bunch of additional resources. So let's rename this TextMesh Pro item to represent what it actually is, and I think we'll call it something like the title. Now remember, when you add UI elements, they are actually placed on a canvas which is significantly larger than your game screen. This allows you to have both items without them running into each other in your editor. So this first game object, or this first TextMesh Pro object, is our title screen. So with it in the center of the screen, we're going to first make sure that it's anchored to the center of the screen. That way, if the screen sizes change, it'll stay in the center. Then we'll use the text tool properties to change how this thing looks. One way to do it is to pick center both horizontally and vertically. Then you can rearrange the size of your text box and it will stay centered in that text box. All right, once it's centered, we can now edit the text to change the content. So we'll give the title, we'll give the game a title. So here's sample game. And there are some pre-built in styles, but we're just going to make ours by using the settings in the TextMesh Pro item. So we're going to make it bold. We're going to make it larger. So make it like 72 point or something, about an inch tall. Inside of here, you also have this vertex color. This is sort of like the local color. And we also have a text Mesh Pro texture or material settings where we can change things there too. If you change things in the TextMesh Pro texture material, then it will apply to any text in the game that uses that material. So if I put a black border around the title here by adjusting the material, all other TextMesh Pro items that use that texture will also have a black border. So here you can also change, for example, the font. We'll go with this font, and we can change the color of that item by going to the vertex color. This will now change the local color of the item. So let's try to make it yellow. All right, so there we have this nice gold text, and we can now begin with the button. So we need to add another UI element, make a button. This is going to be our play button that will take us to the play screen. Once the button's on the screen, put it in position, and we can now go into the button properties and change some things. The text that's on the button is a child object. So I'd like to change it from TextMesh Pro to something meaningful. Here we call it the play, I think play button text, something like that. And so here we're going to change the background color of the button. And let's use complementary. So we were in that yellow gold before. Let's go across the color wheel to something blue and make it a nice contrasting background color. To change the text color, we need to go into the TextMesh Pro object, which is a child of that button, and we can use that vertex color again. Here we could try to match up the same yellow that we used before, or we can use the eyedropper and come and grab the color from our existing yellow text, and that'll get us pretty close. So there we have a basic layout for our start screen. Now, when we click on the button, we want something to actually happen, and so we're going to need to attach an event to the button. Events need to call methods that are in a script somewhere. So we need to add a script somewhere to our game. We could add our script to any game object that's in the scene. I'm just going to use the camera since it's already there. I'm just going to add a script to that, and we're going to call this the, I forget, something like that. All right, so once we have the script added, we need to go edit it. So we'll open up that script in Visual Studio 2022. Here we are in the typical text editor. And in order for us to switch scenes using code, we need to pull in, with this using statement, the scene management functions in Unity. So we add this using statement. This will allow us to use the scene manager object to do things like load new scenes. We're not going to use start or update in this particular case. We want to create another method. So make sure that you're not inside of one of those two, but you're still inside your object, inside your overall script object. So we're going to create a new scene here. A new method here. This method could be named anything. Try to pick a name that is meaningful so when you look at your code later. So here I've picked play button click. Why? Because this is the code I want to run when the play button gets clicked. I'm going to make a basic method without any parameters, and then the code has to go in between the start and end curly braces. So we're going to use the scene manager object, and then we're going to use the load scene method. And the load scene method can take one of two types of parameters. It can either be told which number scene to load. And the number corresponds to the index in that list of scenes when you loaded the scenes in under build settings. So if I said load scene 1, it would load whatever scene is in my list in my load scene in my build settings under item 1. So if we go back to build settings, we'll see that those have index numbers 0, 1, and 2. So 1 corresponds to the play screen. I prefer in my code to actually use the name of the scene instead of the index. This way I don't have to remember which one's 1, which one's 2. I just know that I want the play screen, so I'm going to use a string here and call it play screen. Now it'll go to that list and find the scene that corresponds to that name. All right, save that. And then we can go back to Unity, and our title screen theoretically is ready to roll. So now we need to go make the play screen. Oh, forgot, we have to attach that event. So in the button, find the events list, drag in the element that has your script on it, in our case, our camera, and you'll notice when I go to the list of events, methods that are available, I don't see my play button click. That's because I forgot to make it public. Got to remember to make things public if we want to be able to use them in Unity. So we'll go back to our script, make it public, save it, and then if we hop back in Unity in that event window, we can now go to that event in the button. And when we pull that down and go to the script, there's our public click, our button click event that we created. All right, now we want to save this scene so that we can switch to our play screen and start building it. So go ahead and hit save and then load in the play screen. All right, here we are. We want to start adding things like platforms and players and enemies and balls. Those are all going to use items from our sprite list, so it's helpful to pop that open. And I don't like this blue background color, so I'm going to go to the camera and go to the background sky color here, and I'm going to change it to a nice dark background, make the scene a little less jarring. Zoom back in because you might be zoomed out from that UI layer that you built before. And it's now time to create a platform. So one way to do this is to create an empty game object called platform. And this is going to control the overall location of the platform. And we're going to need a lot of layers and we're going to need a lot of tags in order to keep our game running straight. So let's start by creating a layer. We'll create a player layer, we'll create a ground layer. Some other layers we might want are the enemy layer, a button, a bullet layer, some things like that. These are very common, and we use these to control what runs into what. We also need tags. So we're going to make that platform layer be tag, or that platform be on the ground layer. We also sometimes want tags, and so we might edit the tag list here too. So here's my first sprite, and you'll notice I dragged in my sprite and dropped it inside as a child of my platform. Now I'm going to duplicate it 5 or 6 times, and then I can drag those items out using the move tool, and I can basically create a little platform here. So let me finish that up. There's actually a better way to make platformer levels. It's the tile editor. It's much better than this method, but this method for our simple game is great. Now you'll notice, but because they're child objects of the overall platform object I created, I can drag around that platform and move it to wherever I want it. All right, so now we got to build out this platform. So one thing we want to do is add a box collider so that the whole platform, things can land on it. So add the box collider and then click the Edit Collider button. And then you can drag these little green handles around to make the box fit around your overall platform. All right, that's all our platform needs. And so now it's time to start building our player. So we're going to create an empty object, and we're going to call that object player. And I like to work on things at 0, 0, 0. If you work on them at something other than 0, 0, 0, sometimes the the arrangement for like if you need to build animations or something can get all wonky. Not so important on that platform, but on our player, let's build it at 0, 0, 0. All right, we're going to add a sprite renderer to pull in a sprite for this object. And then we're going to assign the sprite we want to use. If you click the little dot, our assets will open. And I'm going to pick my robot here. All right, if we want this object to understand physics, we're going to add a rigid body 2D. This will give the object mass and gravity and things like that. And we want to be able to collide with things, so we're going to use a collider. Since this robot is strangely shaped, we're going to use the polygon collider. And what that does is it uses a bunch of polygons to cover your sprite. You can edit those too, but it does a pretty good job of guessing where those sprites go. The player is also going to need a player controller, a player control script. So we're going to add a script, call it player controller. And we should now have a rigid body 2D, a and here I'm setting the Z constraint. We don't want our robot tipping over, especially when it like fires bullets or gets hit. We don't want it rotating around. We want it to stay upright. So we're going to just hit in the rigid body 2D, we're going to open the constraint section and constrain it from Z rotation. All right, so with our robot built, it's now time to add some functionality. Oh, we'll test it real quick. Yep, it falls, it stops, it doesn't pass through the platform. That's awesome. Now we want to go edit that player script and add the player control logic. This would be things like moving left and right, jumping, firing, things like that. All right, here we are in the player controller. We have a start and update again. And inside of update, we're going to handle player input. So this is where we will use the input object that is built into Unity. Now, there's lots of ways to do this. For this particular game, I'm going to use key down events. So whenever somebody presses the key down, it's going to make something happen. And the thing that we're going to make happen is we're going to do movement by applying forces to an object. If you're really making a platformer, there's better ways to make this movement seem more platformy. You don't necessarily need to use physics to do it. It's probably better off to set velocities. There's great videos out there on how to do that. We're just trying to get overall a sense of how to interact with Unity, and this is a very simple way to do it. All right, with everything else that we've been doing, we need to be able to access objects in Unity in this script. And so a lot of times we need to set up some variables inside of our script in order to be able to do things to it. And here I'm creating a local variable called RB. It's going to be the rigid body of the object. And I accidentally used the word rigid body here instead of rigid body 2D. you'll see later that it comes back to bite me, and I come back and fix this later. So if you don't want to go through the process of having it wrong and then fixing it, just make that a rigid body 2D instead of a rigid body. Now, I need to go get that rigid body. One way I could do it, like we did in class, was to make that a public variable and then in Unity drag the rigid body of the player into that script object. Or since this is the rigid body of the player and this is the script of the player, I can actually go get the rigid body from code right here. So on startup, I'm going to just set this variable equal to the rigid body of the player object. This is actually probably the better way when you're working with properties that are on the actual object you are currently scripting. All right, now that I have that rigid body available, that means I can do things like I could push the player, I could do things to it. So we're going to go down and handle this player input. And so you'll see that if I say, if I add this line, if input.get key down, and then in this case, it's going to be the right key, I want to apply a force to the rigid body. I want to apply it to the right. So if I do rb.transform.right, that is a vector that points right. I can then multiply that vector times some amount of force. And I don't know how much force I want to apply yet. It could be 100, it could be 150, it could be 300. So the easiest way to do that, where you don't know exactly how much you want, is to use a variable. Here I'm going to call it walk force. And then I'm going to make that variable public. And this way, while I'm playing the game in Unity, I can adjust the value of that variable until I get a value that I like. This prevents me from having to go back and forth between the editor and the script editor um, and constantly saving and recompiling. As long as I'm in here, I might as well make a public variable for the jump force as well, because I know I'm going to need that. And I know that the jump force and the walk force might be different. All right, if I use the right arrow to go right, I can do this exact same thing. So copy and paste, change right arrow into left arrow. And there is no transform.left, but minus right is left. Minus, in the case of a vector, turns it around. So the opposite of the right-hand vector is the left vector. So the minus sign just says turn right into left. All right, so if I have the moving left and right, I need to be able to jump. So I'm going to get the up arrow key. And when I do that, I want to add the force to make it jump. So it's the same command as before. It's rb.add_force. But instead of multiplying the right arrow by some amount, I'm going to multiply the up vector, which on the screen in Unity, the up vector is that was a green one, yellowish green one, and the right vector is the red one. Here I'm making a note that says, hey, we could do this movement in lots of different ways. One thing that we do in platformer games a lot of times is prevent people from jumping if they're not standing on the ground. This prevents the jetpack effect. Again, we're creating a very simple movement program here and not worrying about those details. All right, the other key command we're going to want to do is to be able to fire something. So we'll do the input.get key down and we'll make the spacebar our fire button. And we'll come back to that. Yeah, we'll come back to this after we test our movement. All right, with the player selected, we can now see the variables from our script, and we'll see that the walk force and jump force are variables. So we're going to pick some values here. So we're going to try it with something small. If we hit play, you will notice that getting some errors. And this error is um, a null reference error. And this is where, or the object isn't the right type error. And this is when I realized, oops, should have been a rigid body 2D, not a rigid body. And so make those corrections here real quick. All right, let's try this again. All right, so the good thing is there's no errors, but you'll notice the movement's tiny, like the robot is barely jumping. So these values aren't big enough. So we can start to begin to play and adjust, and you'll notice that this time, if the robot jumps, it jumps a little bit better, moves a little bit. So now I'm starting to get some values here. Um, Remember that if you adjust values while the game is playing, like I just did, after you hit stop, they'll go back to what they were before, and you have to re-enter them. So we'll use some reasonable numbers here for the forces um, to get things moving. All right, the scale of the object. You can see that if I put a -1 in scale, it actually flips the object around. So if it's facing to the right, it has a scale of 1, and if it's facing to the left, it has a scale of -1. This will allow us to do some better movement. So when the robot's moving left, I want the robot to face left. And when the robot's moving right, I want it to be able to face right. So we'll go to script and we'll add that minor change to our movement code. So when he faces left, I want him to have a negative scale, -1x scale. And so I just set the local scale equal to a new vector, which is a -1 in the x, a 1 and a 1 in the x, y, and z, because I don't want to modify it in the vertical direction. I want them to stay positive. I don't want them to flip over. And then I do this I just copy and paste this code when I face right. So whenever I push the right key, I want to make sure he's facing right. And whenever I push the left key, I want to make sure he's facing left. And you'll see that he now turns around whenever he moves the direction that's indicated. There we go. Makes much better player movement than before. Next up is going to be shooting. So we need to add a gun position. And so I'm going to call it gun point. And I'm going to move that to be where I want it, the the shots, the laser blasts in this case, to come from. So I'm going to put it here near the end of his eye. I'll zoom in here a little bit and get a better sense of where I want it. I could put it directly over his eye, but the bullet shape that I chose to use is this kind of long, laser blasty kind of effect. So I think it looks better if it comes out from a position a little farther out from the eyeball. The other thing I need to do is I need to create that bullet prefab. So I'm going to go back to my sprites list and I'm going to grab that bullet or blast icon image and I'm going to drag it out into my hierarchy. And again, I'm going to make sure that this is at a position of 0, 0, 0. And I'm going to make sure that it is scaled to look like a blast. So I'm going to actually use a tiny bit of scaling that's different and set it equal to maybe 0.8 times its original size. Since I'm going to shoot this thing using forces, I need to add a rigid body. And since I want it to collide with things, I'm going to use a box collider here because it's basically the shape of a rectangle. And in the rigid body, I'm going to set the gravity scale to 0. I don't want gravity to affect this thing. I don't want these things to be lobbed out like a cannonball. I want them to go shooting straight forward like a laser blast. On the collider, it's potentially interesting to make them a trigger. And triggers are like they collide, but they don't collide physically. We're going to leave it as a collider so it'll actually bump into things. Physics will apply to it. But colliders that are tagged as triggers are really effective in arcadey style games. All right, here's where I talked earlier about tags. We're going to add tags. We definitely need this bullet to be tagged as a bullet. We'd like the player to be tagged as a player. It's just going to allow us to know what's running into what. we can use those tags in our code to find out what hit what. Here I'm adjusting the player to be on the player layer and the bullet and to be tagged as the player. All right, now that I have the bullet sort of the way I want it, I'm going to drag it into the prefabs folder to create a bullet prefab. This will allow me to instantiate bullets that are exact copies of the bullet we just built. Now that the prefab is created, I really don't need the bullet that is in my scene anymore, so I can go ahead and delete the bullet from the hierarchy. I have that prefab copy of it now. All right, now it's time to go back to our player controller and to write the code that is going to instantiate bullets. So in order to do that, we need to add some stuff at the top again, some variables that are going to allow me to connect to the things that I need to connect to. So I need a prefab that will be the bullet that I instantiate. So that's going to be a game object, and I'm just going to name it laser prefab. This is the laser blast that is going to be created each time I push the fire button. I also need a transform. Oh, actually, I need a laser force. This is how much I'm going to push that bullet with. This is very similar to the walk force and jump force that we created before. Next up is a transform. This is going to be the thing that contains the location of the gun point. So that'll be public, so I can attach it to the player gun point. And um, it's a transform because the only thing I really need about that game object is its location. So with those three variables created, I can now get ready to do some shooting. So I need to instantiate a laser blast. I need to locate it at the end of the gun, and then I need to give it some force to make it shoot off in the direction that the gun is pointing. So I'm going to create this game object. I'm going to name it blast. I'm going to use the instantiate command here, and it needs to know what am I going to instantiate, and I'm going to instantiate a copy of that laser prefab. And now I can use the gun point location in the instantiation to make it get created right at the spot where the gun is. So I'm going to go transform.position. And then the next command is this weird thing called a quaternion, and it's quaternion.identity, meaning a quaternion is a way of describing how something has rotated. And so quaternion.identity means not rotated. So that means the blast comes out and is just pointed in the right direction. And then I'll do blast dot, and now I need the rigid body of this blast. This blast is a full-blown object, so I need to get the component of it called the rigid body 2D so that I can access things that are about the rigid body. So I do that, and then I can do add force after that. Which way do I want to point it? I want to point it in the same direction that the gun point is pointed. So it's gun point dot right. That is the vector. And then I want to multiply that by the amount of force I want it to, in this case, the laser force. It's going to be my value of how much strongly I want to push on that bullet. All right, so when I push the space button, I create a blast object, and then I add force to that blast object. That looks pretty good. All right, let's save that player control script. Let's go back over to Unity and give it a test. All right, before we use the script, I need to pull that prefab into the slot so it knows what it's instantiating. So I do that by finding the bullet prefab out of the assets list and dragging it into that location. I also need the location of the gun point. So I go find the gun point in my player object and I drag it and drop it into the gun point variable. All right, testing, here we go. Well, I'm creating bullets, but they certainly don't look like bullets, right? They kind of just sit there. Those are pretty anemic bullets. And part of the problem is they're running into each other. So we're going to go into the physics 2D section and onto this layer matrix. And we're going to find the bullet layer, and we don't want bullets to run into bullets, and we don't want bullets to run into the player. This will help us so that they don't actually run into each other. And the other problem is I forgot to give it a bullet laser blast force. So I'm going to make that force something big so they go flying out pretty fast. So we'll try 150. All right. So this hopefully will make it so those bullets go out from the player. They don't run into anything, and they fire. Well, there we go. We got firing. They're a little slow. So I think we could improve our force by bumping it up maybe to 300 or something. And now if we fire, those are looking better. All right, but we turn around and we shoot ourselves. We shoot right back through our own noggin. So that's not good. And we also notice that we have this long, huge list of clones of our bullets still going off into nowhere. We'll take care of that with some cleaner objects. But we really want to figure out, you'll notice that when I turn around, the red arrow, the right arrow of that gun point, doesn't get flipped. So I need to maybe do a little bit of smart coding here to make the bullet shoot in the right direction. All right, let's go back to our shooting code here and see if we can make an improvement. I, I really want to make the gun point multiply by whatever value the x is. So if the local scale.x is -1, it'll flip the right vector around. So I'm going to use that local scale dot scale dot x, or sorry, transform dot local scale dot x, and that should make it so that when I shoot left, bullets go left, which it does. I've flipped the fire direction vector around. But you'll notice the problem now is that bullets are always facing right, even when I'm shooting them left. So I need to do the same trick by flipping the bullet around before or after I create it. So here I'm going to take and access the transform local scale of the blast. And I'm going to flip it around if it's pointed left. In other words, I want it to go the same direction as the transform of the local scale of the robot. So I'm just going to set it equal to that. So when the when the robot's facing right, the bullets should be facing right, and when the robot is facing left, the bullets should be facing left. Make the bullets face the same direction as the robot. So that's what that line of code does. So I think this is a pretty creative little way of coding that change. I didn't have to do anything really complicated. I already had the information stored in other variables. And let's see if we get bullets shooting right and left. The other option here is just make your bullets circles, in which case it won't matter. You don't have to go through all this trouble. And once again, I think I forgot to reset my bullet speed. They're awfully slow again. So I'm going to go back to my bullet thing and set that bullet force back up to something a little bit more powerful. So 400 should make those things zip along nicely. Yep, there we go. Well, now we can shoot. It'd be nice if we had some things to shoot at, and it would be nice if we didn't fill up all of our game memory with bullets that are traveling off into nowhere. So let's take care of some cleaners and then create some spawners to create our enemies. To create the spawners, we create an empty, the cleaners, we create an empty game object. This is one way to clean up stuff that you don't want anymore in your game. You can create off-screen colliders, write a little bit of code that will destroy things that hit it, and it keeps your game nice and cleaned up. The other way you can do it is when you spawn the actual object, like you spawn the bullet, you can give that bullet an ability to have a lifetime. So it only lasts for a certain period of time, and then it will automatically destroy itself. Um, the reason I'm showing you these cleaners is that they can have other value, like if your player jumps off the screen and he's supposed to die when that happens. That's another good thing use of these cleaners is when game objects leave the screen due to something that's happening on the screen. So we create a empty game object, call it cleaner, move it off screen, and add a square box collider to it. Adjust the box collider to cover the edge of the screen, and then we need a script that's going to run on that cleaner. We don't need the update or the start method. We just need a collision. So we do on collision enter 2D. So when anything runs into it, we're going to run this code. And the simple thing to do is just destroy anything that hits it. So we're just going to say if the collision is not null, in other words, if this is a valid collision, destroy what ran into me. And the command is destroy, and then you just need a reference to the game object that needs to be destroyed. In this case, in this case, the object that ran into the collider is passed in as part of this property, this parameter called collision. So I'm going to destroy collision.gameObject. All right, let's test out our cleaner and see if it takes care of those bullets. Yep, you'll notice in the hierarchy that they are not stacking up like they were before. They're disappearing after they move off the screen. So if it works right on the right, we can duplicate that object and put them on the left-hand side and the top and the bottom. Here again, you're better off to work with the object at 0, 0, 0. So here I'm adjusting the horizontal one to exist around the 0, 0, 0 point, and then I'll use the move tool to move that thing to where I want it. And I'm going to move it kind of a little bit off the bottom of the screen so that if the player falls, it will completely leave the screen before it gets destroyed. Same thing with the top one. I'm going to move it off the top of the screen some distance in case we do a jumping thing on the screen. You know, the object could partially go off the top of the screen without being destroyed. All right, bullets are being destroyed. Let's see if the robot gets destroyed. And yeah, you can see in the hierarchy that the player is gone. Um, We probably don't want that to happen, though. We probably want to write some code to deal with the player falls off the platform, like reset the level, decrease a life. If you run out of lives, go to an end screen, something like that. So that's what we're going to build next. Is more of a game life cycle that goes with this screen. In order to do that, we need to distinguish between whether the player hit the cleaner or whether a bullet hits the cleaner. If a player hits the cleaner, we need to do end of game type stuff or decrease lives or something like that. So the way to do that is you can access the tag element of the game object that hit the cleaner. If the tag element is named player, like we named it, then we can do special stuff for the player. And um, what do we want to do? Well, let's start off by resetting the level. So we're going to use that game engine scene manager again, scene management, and then we can use the scene manager object to load a scene. And in our case, if we fall off and we die, the scene we want to load is actually the play scene again. We want to reset. We want the player to go back to his starting position. And so I'll just load the play screen over again. And it works. You jump off the player or platform, you die, and you reset back to the beginning. The rest of the game still works. Pretty cool. All right, next up is we want to add some score and, oh no, we want to create some enemies. We want to create the spawner script. This is going to um, be a spawn point. And if you create this as a prefab, so we're going to create it in the scene, create the script that goes with it, and then we'll save that spawner as a prefab. And then the great thing is you can grab as many as you want. So if you need lots of locations where enemies would spawn, you can just grab the prefab and drag it back into the scene. So we're going to make a spawner script or an enemy script. Um, and that script will instantiate enemies very much uh, like the bullet. So we'll use the location. The techniques are very similar. I'm going to let you watch that part without me talking your way through it. All right, we have all the pieces that are set up for the spawning of the enemies. So let's talk through how this script is going to work. We need to have access to our ball prefab that we just created. This is going to be very similar to the way that the bullet prefab was used. So we have our enemy prefab object, we have our transform to contain our spawn point. In the start section, we're going to grab that spawn point as a transform. Technically, we could just have used the transform of this script, but I like to remind myself that this is actually the spawn point. All right, we are going to randomly generate an enemy every few seconds. So it's nice to have a minimum time. So in other words, no enemies will get spawned shorter than this time, and then a max time where we will not wait any longer than the maximum amount of time. These two values will get used to generate a random number somewhere between the min and the max, and we'll use that to generate or call the spawn function after that many seconds. So here we're writing the spawn code. This is the routine which will actually generate the new enemy. This method looks a lot like the bullet call or the bullet generation. It's going to use the invoke method to create a copy of the enemy. I meant instantiate, not invoke. All right, so we've instantiated that object at the spawn point, and we now need to call this function again after a delay. So in other words, whenever we spawn something, we want to wait some period of time and spawn another one. So the last line of the spawn code is just calling spawn over again, but after a certain period of time. And the way we're going to get a random amount of time is we're going to use this method in the random object called range, and we'll put in our min time and max time as our input to the range function. So this will generate a random number somewhere between min and max, and then the invoke method will wait that amount of time in order to call it. And we'll use that exact same line in the start function. So when this spawn point first gets created, it will wait a random amount of time to spawn the first enemy. That will call the spawn code, and the spawn code will then wait, will actually spawn the enemy, and then wait in a period of time to call again. So once this thing starts running, it'll just continually spawn enemies. You could add a bunch of code to this to check for like the maximum number of enemies. If the enemy at this point is already existing, you wouldn't spawn until after it's dead, things like that. In this case, we're just generating a constant stream of enemies. Now that we save that code, we're back in the Unity editor, and we have to set those min time and max time, or we won't have any enemies created. And there we have an enemy being spawned. All right, next up, let's see if we can shoot these things. And yes, we can hit them because they have colliders and rigid bodies and they move, but that's really not the effect we're looking for. We're trying to shoot them and destroy them. So we should write some code to handle those collisions and not end up with a really strange game um, that looks like you're throwing batons at things. So that looks pretty cool, but isn't exactly the game effect we're looking for. So here we're going to handle the collision detection. And again, you can put this collision detection on either of the two objects that's doing the colliding. So we could put a script on the bullet to figure out what it has run into, or we can put the script on the enemy and figure out what hit it. In the case of the enemy, where I might want to do points or damage to the player or things when things hit it, I'm going to put the script on the enemy and then decide, did the bullet hit it or did the player hit it, etc. Um, so once we know that we have a valid collision, we now need to check to see what hit me. So we're going to check to see whether the game object is tagged as a bullet. If it is a bullet, now we have to decide what we're going to do. Well, first we're going to destroy the bullet. Remember, collision.gameObject contains the item that hit me. So in this case, I'm running on the ball. So collision.gameObject is the bullet. And then the second line, destroy game object, is cleaning up the um, the ball that got hit. The other thing that might hit the ball would be the player. So we need to decide what happens when the player hits the ball. This could be something like we could reduce the number of lives, we could destroy the player and end the game, we could apply some damage to the player, all sorts of things like that. So that's why we have a different if statement here that distinguishes between what hit the ball. So in our case, let's just switch scenes. Um, let's reset the scene, and we're going to do that by using the scene manager again to just reload the scene we're currently on. So it'll kind of put the player back to the beginning and clear out all the spawns. So it'll look like a scene reset. All right, let's hope that when we shoot things, they will get destroyed, and when we run into things, we will see it um, get reloaded. All right, that's great. Look, the balls are disappearing, the bullets are disappearing, just what we were expecting. Starting to look a little bit like a game. All right, let's fly over there. And look, we're back to, I ran into an enemy and I reset back to the beginning. So it is behaving the way we want. Here, I just added a little bit of code to destroy the player and the ball when you hit it. It makes it look a little cleaner before the scene reset. All right, now that we have the balls being destroyed, it'd be nice if we could keep score and how many lives I have. So this next stretch is going to be building a UI score element on the screen. Um, this is going to get fairly complicated because I'm going to use a third game element. I'm going to use a different game element called the game status. And that's where I'm going to store the variables of the number of lives I have and the scores. Adding these text elements that are coming up, these are the same as the technique that was earlier in the video on how to add the um, the uh, the title text. The difference is we're going to eventually write some code that allows us to change the value that's on these UI elements. You'll see that later. I'm not going to talk through all of this. I want to get this thing posted and I'm starting to run out of time. So I'm going to let a lot of this run without voiceover over it. So see if you can follow along and I'll try to jump in with some highlights here and there. All right, we've created this game status object, and we're going to put a script on it. That's the only thing this game status object is going to be, is a script. It's going to contain some variables. So we'll go ahead and our game state object. So we'll go ahead and give ourselves a variable to keep track of how many lives you have, and another variable to keep track of how much score you've accumulated. We'll create a little routine that will return um, the string version of this score. We'll use that routine to call when we want to update the on-screen TextMesh Pro object. There's lots of ways we could have done this. We could have done this with a public getter on a on a on a string item. I just thought this was a little clearer code-wise. This is not the way I would have written it had I been writing it for myself. Repeat the same idea for the lives. Perhaps the simpler thing to do would have been simply to make lives and score public, and then we could have just accessed them from wherever. It's probably the way I would have done it had I thought through this from a simplicity standpoint before I made this video, but we're stuck with the way I recorded this, so here we go. This update score method will be a way for us to pass in a change of score S into the game state. So we'll call this whenever we want to modify the score. So give plus or minus, etc. Same thing for lives. We will do a way to update the number of lives. All right, now that we have the game state script set, we now need to go ahead and try to apply that. So that'll be us modifying the other scripts, like the player um, controller. The player controller will allow us to, I think update the screen would be a good choice. Um, so you can see how I access the game state script from other places. So we're going to need an object to, we need this game state object, and you'll notice it's of type game state, not game object. This is the state. This is the same name as the object I created in that script. And then we need to get a reference to it so that we can actually uh, access it from here. And so we're going to use the method of going to find it. So we're going to tell the system to go find any game object that is named game state. All right, and so if it finds the game state object, we need to actually access the script portion of it, which is the component. And so we'll have to actually go in and find the right piece of this, and that'll be next. So there you can see we went and found the game state object, and then we want to attach to the game state script on the object. So now this local variable called game state, lowercase game, lowercase state, uh, is a entry point into that other script. So I should be able to manipulate the score or retrieve the score and display it on the screen using this using that object. All right, this is going to show how we would set um, our score. In order to do that, we need access to those TextMesh Pro um, text elements. So we'll go ahead and create a couple of variables to uh, access those. All right, now set the text element of that score TMP object to GameState.score or get score. This will return the string version of that number, so that can be displayed in a text element. And we'll do the same thing with lives. All right, if we jump back into our enemy script, we can begin to handle what happens when an object gets hit and we want things to score. So we need that game state object again because we want to be able to write and change the score as things happen. So we'll do the same thing we did in the player script. We'll just get that game element. So when the bullet hits a ball, we want to increase your score by 1. So we'll call that update score method from the game state object. We'll pass in a positive 1, which means that the score will go up by 1. Next, we'll do the same thing in the player collision. We're going to reduce your lives by 1. Uh, we don't have an update score method. So I think here I finally realized that I'm just going to cheat and, oh, I do create one. All right, so I'll create an update score, update lives, same idea. We'll pass in a parameter. We'll call it L for the lives. And then we will adjust the private variable, the lives, by the amount um, that you've passed in. So lives plus equals L, which means take whatever L is and add it to lives. So if we pass in a -1 value, we would decrease the life by 1. So there, back in our enemy script, we decrease the life of the players by 1. Here we're adjusting the cleaner script. So if the player falls off the platform, we should do the same thing. We should modify the game state to reduce the player lives by 1. So we're doing the exact same thing to the cleaner script that we did to the enemy script. We're getting access to that game state object, and you'll notice that we had earlier deleted the start method of the cleaner script because we didn't think we needed it. But now we need it because we need that when the cleaner first gets created, we needed to get access to the game state object. So I added it back in, and we are going to do the same thing we did before. We're going to update the game state life by 1, by -1. Now here I'm going to see if I can check to see if the lives have gone below 0, and if they are, I want to change the scene from the play screen to the end end game, like the game over screen when you get to zero lives. Um, I'm not sure that I end up using this code in the end. I think I might make a different modification a little bit later, but we will see. This don't destroy on load is when I load a new scene, all of the game objects in the current scene that I have open go away. And if I want to display like high score or something on the end game scene, I want to know the score that the player got when I go to the end game scene. I need to tell the scene manager that it should keep that object around. So you'll notice that I told it to do not destroy um, on load the game object. And I think that was, yeah, the current game object I was writing the script on, which was the game state screen. Um, and so then when we uh, use the scene manager to load the end screen, the end game screen, um, the the game state object should theoretically still be there for us to access if we wanted to read the score and print it on the screen or something. Now I'm going to add these score updates to update so that every frame it'll check to see if somewhere else in the game somebody has modified the score or the lives. Um, this should make that text update continuously. Not sure if this is the most efficient way because I'm asking the game engine to every single frame write and look up something. There might be a faster way to do this, but for our purposes, this game is not about performance. It's about watching and seeing things happen. These null reference errors are because I forgot to put my TextMesh Pro objects into my script. So we will take care of that problem. And now my script should be able to access the objects it needs to. Try this again. All right, I lost a life. I'm getting points. If I jump off again, my life is now down to 1. My score and lives seem to be working. And if I jump off or run into the ball here, I should lose another life. And it reset back to 3. It doesn't seem to be handling the dying properly, so that I go to the end scene. So I think I'm going to swap this around and handle that death and change over in the player script instead. In order to do that, the easiest way is to modify these game state variables of lives and score to be public. This way I can grab them from outside, so I can use them from inside of players controller, or the cleaner, or the um, or the enemy script. And so on the cleaner script now, if I have greater than 0 lives, I load the play screen. But if I have less than 0 lives, I load the end game screen. Um, and then I can do the same thing on enemies. I should have just copied and pasted that code from the other script. All right, let's see if our whole game cycle will work. So let's get on that title or end screen. We need to build an end screen here real quick. And we'll add some text and things to it so that we can recognize when we have reached the end of the game. All right, last thing that I want to do is I want to show you how to play a sound. So what we're going to do is we're going to go find a sound clip. This could be like an MP3. So I pull in the sound of a cannon firing here. And you can test your sound by clicking down at the very bottom of the screen. There's a little player at the bottom of this inspector. And you'll notice that I'm looking around and trying to find where to play it. Oh, there it is. All right, so now you can play it and you can hear the sound of the cannon firing. All right, so now that I have that, I want to go play that whenever I hit the fire button. And so that's going to have to happen in my gameplay screen. So I'm going to load the gameplay screen again. I'm going to go to my player object and I'm going to edit that script again, the player script. And I need, again, up at the top, whenever we're going to work with something from Unity, we need some stuff in our script. So this would be the stuff that we need to handle sound. And here I'm going to use an audio source, and it actually is wrong. I use audio clip here, and audio source is actually the right one. So I started to type the right one, and then I used the wrong one. They do different things. So here I call it audio clip cannon. I fixed this problem a little bit later. So if you want to skip forward for about a minute, you can skip all my mistakes. But audio clips are sort of like you load them in and play them. Audio source actually has a clip associated with it and is already preloaded and ready to play. So here I try to play the laser thing and there's no way to play that clip. So I then realized that, oh, I need a audio source. So I'm going to change gears here shortly. All right, add component, go to audio, pick an audio source. That adds it to the player object, and then I can drag my clip for my cannon into the audio source. So this audio source is now set to play that, and we do not want the play on awake checked. We don't want it to play right when the player gets created, because as soon as the player object gets created, it would go boom. We don't want that. We're just going to play this when we want to. All right, so that's there. Now we need to change that code up above to be an audio source instead of an audio clip. And now down below, when we want to play the cannon sound, we can tell that audio source to play. And so I'm going to say audio source or laser dot play. And play one shot seemed really appealing here because I only wanted to play once. And then I realized, oh no, that's actually for playing an audio clip that you don't want to preload. You just want to load it, use it once, and throw it away. So the actual command here is play. I want the audio source to play, and the audio source is associated with the cannon. All right, I'm going to save that, and then over in Unity, I have to now attach this audio source to the laser audio variable. So I'm going to save this, and you'll notice in the script that I get that variable for audio source here. I'm now going to drag my player object onto there, and that will assign the audio source object to it. All right, now theoretically, we can hear cannon sounds go off when we hit the fire button. So let's give it a try. And sure enough. All right, that's your basic game. Hopefully you can use information from this to get your basic game set up. Some of you will be using platformers like this, and a lot of this will be applicable. Some of you will not. So good luck.